This is a paper that was published in the IEEE Futures Conference last year, which was basically Next G Managed Access System for Correctional Facilities. Basically, this is a kind of a design proposal for a development of a managed access system, which is typically needed in um, to manage the access for a campus, and particularly campus like correction facilities and jails, where jailmates try to bring in the phone illegally and try to connect and use the phone, and that creates a lot of damage and trouble and crime outside. Um, the so this leakage from the managed access system is a big issue, um, and uh, and this is a problem not just within US. This is a problem at a global scale. And so mass, those who don't know about mass, mass has gone through two iterations of development. The first iteration was 2G based iteration, and that iteration was basically around using the BTS in the middle. So mass is acting as a BTS in the middle, and it covers the campus with that BTS in the middle, and then you try to connect to the uh, to the phones inside the campus, and only transmit that as allowed beyond the BTS, and those which are not allowed, you're able to figure out where they are coming from and would you be able to catch them. That system, that first iteration, is still in use. A lot of facilities are still using that version, which is 2G. And unfortunately, 2G is reaching end of life. And the technology is falling behind for those facilities, and it's growing the risk. The second iteration uh, is developed by CTIA as a standard in collaboration with Virginia Tech. And they are using a roaming model. So what they're trying to do is they install the RAN inside the campus, and they treat that RAN as a roaming network with its own PLMN, and once the phone is connected to that to that to the campus RAN, then it decides to kind of connect to the host operator based on whether the access rights are available or not. The main problem with that model is that because it's using roaming, it competes with the host operator signal inside the facility. Also, if the phone is has a 5G capability and advanced 4G capabilities, many phones prioritize connection to the home operator if the signal is available, and even if that signal is weaker than the roaming signal. That's basically to avoid roaming charges for a normal phone. So that again has a potential of leakage and is a problem. So to solve this problem and also to develop the technology and solution, standards-based solution that can be used for 5G. I think there's a critical need, and the proposal here is to use the design that we proposed in IEEE Futures conference um, as a template for the standard IEEE standard for managed access solutions, and develop it for as a third generation or third version of this mass standard. Um, any questions so far?
No, Praveen, you're doing fine. I think I was just talking to Purba about when you go through this, if you see a potential area that can be part of IEEE standards, basically the way it works, I don't know if you listen to Alex, we have a process like project authorization record. You probably are familiar with that. We are trying to write a white paper now based on the proposals we received. We call them maybe subpar or something like that. And then potentially some of those can be taken into a par process, right? So par means it'll follow up, go through the whole standardization lane and sponsored by IEEE SA. So during this presentation, if you see there's a potential either use case or a specific thing that like a framework we can propose as a standard,
Yes.
right?
So all the following slides are part of that proposal, actually,
Excellent. Thank you. Yeah.
And can
Yeah, please
be
continue.
used. So Open RAN creates another opportunity for this use case because now that the E node B and G node B is now divided into CU and DU and RUs, and that creates a additional opportunity of developing something as a managed access solution, which can be part of the mobile operators. IAB is internet access backhaul is another technology which can also be used for connection at the mid-haul level from CU to DU, and that creates also additional option of being able to connect to multiple CUs via IAB and get support. Using F1 and IAB, what MITRE is doing is that MITRE has developed a hybrid RAN concept. And in that hybrid RAN, what we are trying to do is using this mid-haul, we are connecting the campus RANs to the MNOs. And by connecting the campus RAN to the MNO via mid-haul, we are essentially extending the macro network by connecting the small cells, which are the campus RANs, to the macros and extending the network inside, extending the access inside. Now you can install this small cell as a neutral host. You can also install this as a private RAN, which is then shared with the operators. And that creates a hybrid 5G solution for the campus, which not just supports private users if there is any private user, there's a need for private user, or it can also be acted as installed as a neutral host where multiple operators are supported, and the campus RAN is connected to multiple operators via mid-haul. So this technology is being standardized via ORAN Alliance. We have contributed this to ORAN Alliance. This is one of the use cases which is part of ORAN Alliance use cases. and would be released as part of the June train of ORAN documents, ORAN Working Group 1 use case analysis document. And we are also following up and specifying it further to create the use case specification document for ORAN. So using that idea, extending this idea of hybrid 5G, the proposal here is to develop a next generation managed access solution. And what we can do as part of this managed access solution is deploy this RAN sharing via mid-haul as a managed access node for the campus. Support all the three operators using that this managed access solution as a shared DU, and connect it to the CUs of multiple MNOs. This way, we will this managed access campus RAN will be part of the traffic for all the three MNOs in the US, and same can be achieved for at a global level in other regions as well, based on what operators are available in a certain campus, and develop a managed access solution in which we are not just extending the MNO coverage inside the campus, but we're also detecting if unauthorized access is being done, and block that unauthorized access as part of a managed access. So this particular standardization goes beyond what we have. We are standardizing in ORAN and builds on top of it, basically as a vertical application for the hybrid RAN. So here, what we are doing is, so this is the private RAN as an example, which is deployed inside the campus, and it then connects via mid-haul to the CU of the MNO, and then because of we have this mobility, RRM mobility, we have RRM or RRC in the radio resource control in the CU. The mobility of the user inside is very smooth, and we are no longer in competition with the signal of the with the signal of the carrier. In fact, we are extending the carrier signal inside the campus, and whenever the mobile is moving into the campus or is used inside the campus, it would access via the access node to the CU, and then the access management can be done. So this is a en masse RAN sharing architecture which is proposed. As you can see, the ODU basically is along with all the RRUs which constitute a campus RAN, is partitioned into multiple partitions, and is then used to connect and provide service for all the different operators that are available in that country or nearby the campus. And this way, then the mobiles of all the operators would be using the campus RAN to access and would enable a managed access quite successfully even for 5G phones, um, and we would be able to catch up with the technology for this use case. Um, so, I mean, basically, the way it works is that using a single frequency band, which could be a licensed band from one of the operators, uh, the, the campus RAN managed access RAN is deployed, and then we support that for all the three PLMNs of all the three operators, and then connect to these operators either via F1, wired F1, or via wireless IAB to these operators. And since this technology is standardized from an operator perspective, we would still be standard compliant for this managed access solution. In terms of the call flows, so one of the key things that we have to, so one of the changes, important changes that 5G did, which is not part of 4G, is the use of encrypted identifier for authentication, and that's called SUKI, subscriber, you know, um, unique encrypted identifier, something like that. Instead of SUPI, subscriber unencrypted. So in 4G, for authentication, IMSI is sent in clear for authentication, and you are able to do the IMSI-based authentication, and you are able to block the authentication for unwanted users in 4G. But in 5G, if it is a true 5G, though a lot of operators are still using 4G authentication for support of 5G because they're only supporting 5G for the user plane traffic and not for signaling and not for control plane. So then we should be able to use the 4G mechanisms for access management. But wherever and whenever the operators moves from the SUPI to SUKI, then we need some additional mechanisms to be able to identify the user reliably, because for SUKI, actually the IMSI, the SIM card is different, because now in the SIM card you have the public key of the operator provisioned, and the IMSI is encrypted with that public key and is sent over the air. So it's a different SIM card that is used in 5G for access to maintain security. And if we are using, so for 4G, we can use managed access. Uh, we can develop managed access without any extra functionality beyond the BBU interface that is available. But for the 5G, we might have to use something more than just the ODU, and connect to the OCU at the operator level. We might need some kind of a proxy of AMF, which would be required so that we can get the SUKI decoded by the MNO and return it back to the managed access node, and then we will be able to block access. So that's another component of standardization that we might have to do as part of this, beyond support of hybrid 5G at the ODU level. So that is my design proposal, and would like to
So,
kind of
Praveen,
address any feedback.
yeah, thank you. Did you listen to Alex Gallman's the whole RRSA standardization? If you haven't listened, that's fine. We have a set of processes how to proceed from RRSA. I mean, consider this as a RRSA or pre-RRSA type, where we collect proposals and look for potential items that could be standardized. And through Industry Connection, which is hosting this event, so there is an IEEE Open RAN Industry Connection. And so we had the summit yesterday. Today we are discussing multiple proposals. All the talks, including yours, have been very useful, and they propose some new things that could be done. Will complement what else is going on in ORAN Alliance elsewhere. So what I was thinking is you have a specific item, right, that you think could be pursued within IEEE SA as part of PAR. And the way it works is right now, I know the very first proposal, Chatai had a write-up. In fact, he almost prepared a pre-PAR. Some of the subsequent presentations were mostly
Ashutosh, you're breaking up.
although some of them were little focused. So in this case, if you want to standardize, one of these you think could potentially be standardized? You're able to hear me, right, Praveen? Praveen, we cannot hear you. Or I don't know, am I audible? He's on mute. Praveen, were you able to hear me what I said? Oh, okay, maybe he has a connection issue. So when he gets back, I think he probably had connection issues. So maybe we lost him. All right, we'll give you a minute or two. Otherwise, you move to the next speaker. I think. Let's see. Praveen, are you back? Okay, we'll give him a time. So we got two more talks after this. I think the last talk I thought was supposed to be video, but looks like the speaker is already there. Kanadhan, you are there? Are you online? All right. So our next talk would be, let me see. I think from Virginia Tech.
Yep. Hello, I'm here.
Olga, you're here, right?
Yep.
You can wait for maybe 2-3 minutes, otherwise we'll start your talk. So far, as I was describing, folks who didn't get a chance to even propose, at least you're listening to the whole process. This will give you an idea exactly. If you have any new idea, then you can contribute. We have a monthly meeting coming up sometime next week to the Open RAN working group. We got about like 250-60 members. If you have not joined, you'd like to join, you can always join that, subscribe to the mailing list. And we could not hear from Adlan from Eurocom today due to time issues, so I'm going to invite him. He's going to talk about service-oriented network for Open RAN. That would have been a good talk as well. So with that, since we lost Praveen, Praveen, until you're back, maybe we can get back to him. Olga, would you like to proceed with your presentation?
Yeah. So Ashutosh, I'm back. I'm sorry.
Back? Oh, okay. Yeah. So there was, I think, I don't know when we lost the connection. The question I had was, the part of the whole RRSA process is to collect potential items. That's what we are doing today. And the next step would be try to crystallize it a little bit, maybe put it in 2-3 page format. Exactly what part of this you think could be potentially standardized. And we're going to collect all those, compile those, and make it like a white paper, IEEE Industry Connection, Open RAN white paper. It could involve use cases. It could involve new framework suggestion, could involve new entity like heterogeneous RIC, the LEAP suggested. And there are some interesting proposals from integrator, best current practice, things like that, right? Or guidelines. So in that situation, Praveen, my question was, which one out of this you think could potentially be standardized? You don't have to say it now, but that's something to keep in mind.
Yeah. So basically, the concept of managed access using RAN sharing is the portion that would be.
I think that's a good one, right? In my view, I think it's a good one, good use case. What else we can be? So there is a question also in the chat. What is the actual expected IAB uptake by carriers? My understanding is that there's not been a lot of interest so far. Would you like to comment on that?
Yes. So IAB is under evaluation by the operators. I think for extending extending the coverage indoors, IAB is a good technology. Though operators are not adopting it for deploying it as part of their own network, because then it eats the bandwidth. It's the spectrum is not efficiently used because you're using the same spectrum twice. But in this particular case, because you are offloading the traffic from the operator to the private RAN, IAB can be a good option to deploy. And that is something that would be evaluated as part of the ORAN, as part of the deployment of the use case by the operators for indoor coverages.
Thank you. So excellent. So one more thing, I know this is a paper that you published last year, right? In IEEE.
Yes.
Have you done any like future work in terms of results, analysis, simulation, how it works, the challenges with your concept, right? The one you presented today.
So we did one simulation using MATLAB around IAB concept itself, as to how as we go behind one wall and behind two walls, how the operator coverage dies down. And if you have an IAB where you have the IAB on outside the building or outside that wall, and then bring the coverage inside, how you're able to improve the link link values. So we did this link analysis, 5G link analysis using MATLAB, and you can so we found it very useful in proving that IAB is a very good use case, especially when you go behind walls.
Right. No, because one of the things, we had series of testbed talks yesterday as well, and we're trying to see any simulation experimental results also included as part of the white paper as well. So
yeah, sure. So we have not done any. The way MITRE works is we need some kind of funding source to do more implementation type work. So if there is enough interest in the IEEE community, and we have some industry traction, then we might be able to pursue this.
Okay, yeah, that's fine. Any other question, folks, from the Braze? Otherwise, I'll move to the next presenter. No? All right. Thank you, Praveen, for your contribution. I think it's important to consider all these aspects for operational, to reduce the operational complexity.